moving forward for a session that is fundamental to the modernization of agriculture, rural and renewable energy. Energy is the engine of productivity, and today we explore how sustainable power can transform rural landscapes. To lead this discussion, it is my great pleasure to introduce our session chair, Professor Dr. Chayan Kumar Saha sir from Bangladesh Agricultural University. Professor, we welcome you to the dais. Now, for the keynote taker, I would like to request Dr. Mukesh Yadav, Senior Divisional Engineer, Ministry of Energy, Water Resource and Water Supply, Gandaki Province, to be in front of the stage. Also, I would like to request Engineer Lakshman Prasad Rajak, Chief Engineer, Mahagadimai Metro, Bara, to play a key role of keynote taker in this session. To set the context for this afternoon, I would like to invite our lead speaker, Dr. Mukesh Ghimire, Director of Alternative Energy Promotion Center. Dr. Ghimire, you are supposed to conclude your presentation in 18 minutes. Thank you.
Yeah, thank you so much, respected session chair, moderator, all the respected dignitaries, and ladies and gentlemen. Good afternoon and namaste. I am Mukesh Ghimire. I work with the Alternative Energy Promotion Center, which is the government focal agency for the promotion of renewable energy and energy efficiency in the country. I am agricultural engineering graduates from IOE Dharan, the 4th batch. First of all, I would like to sincerely thank to NSAE and IDE, the organizer, especially Ziddai, for inviting me and providing this opportunity to share some of these perspectives on the energy sectors in this very important conference. So it's always very difficult and challenging after these launch sessions. So I'll try my best to awake everyone and also request cooperation for this active engagement in the session. So today I will be basically explaining about this, what could be the role of this renewable energy, especially in the decarbonization context. So of course I will be focusing on this on the agriculture sector, but I think it will also cover other than agriculture sector also. But the main theme will be basically the decarbonization context. So I'll be explaining basically in these 4 key agendas. The first, I will briefly touch upon the global perspectives on this climate agenda and decarbonizations. What are the different climate goals international set behind, and what could be the implications to Nepal. And second, basically, what does this decarbonization means, especially in Nepalese energy sector, and where we can decarbonize in this sector, including agriculture. So I will not be focusing on this many policy, many theoretical aspects, but I will be trying to explain about few examples actually. What exactly the kind of the different cases are these different examples that basically can contribute for the decarbonizations. And finally, I will conclude with some prospects and key way forward. So without further delay, let me go into this slide. This is basically this, as we are already aware, about this global climate agenda. When we talk about this global climate agenda, it basically comes into this Paris Agreement. When we talk about this after 2015 era, then it will come basically the Paris Agreement. Everybody talk about this Paris Agreement, which happened in 2015. Nepal has ratified this agreement in 2016. Then this Paris Agreement basically sets 3 key long-term strategic goals actually. The first one is this net zero. Now every country has basically set this net zero targets by 2050. Nepal has set this target to achieve this net zero by 2045, 5 years ahead than the global targets. And in the long term, this every country is now basically targeting for this global 1.5 degree centigrade rise on the temperatures beyond this 1990s era. So to set up this and to achieve these global commitments, Nepal also has already raised this, already revised this, all the strategies, including this long-term strategy for the net zero. And Nepal has recently released this National Determined Contribution (NDC) document in 2025. And in every 2 years, actually, government has to kind of monitor these GHG emissions in these sectors. So these are the 3 key documents Nepal has already in the implementation phase. The second thing I just want to describe about this, the carbon emission things. Where does carbon emission comes from? So if we see from the global perspectives, so this is the global perspectives you can see. So the UN body, this who basically manages this all this climate change data and these things, it is called IPCC, International Panel for Climate Change. So they basically classify 5 different areas where the emission comes from. So if you see this, the right side picture you can see here, the energy sector, which basically covers 76% of the global emission. So basically the energy sector is not basically only for lighting, but it also has many aspects on this energy. So it basically contributes 76% of the global emission. And another sector is also agriculture and forestry that basically contribute 15% in the global emissions. So if we accumulate this energy and agriculture together, it will be more than 91% already. So if you see this graph, there is one graph. If you see this graph from 1900 to this 2024, you can see the emission is already increasing in this from the energy sector. So I think if we talk about this decarbonizations, the energy sector is the main sector actually where we need some kind of intervention in this area. So now let me come into this Nepalese context, what actually the Nepalese context is on this energy, so where we can decarbonize in Nepal sector. So I'll try to explain with the first this left kind of pie chart. You can see this Nepalese energy consumptions pattern. So this is the 2024 status of this Nepalese energy consumptions, where you can see the different kind of these fuels or the energy sources, their sectoral consumptions. You can see this traditional biomass, which basically covers 64% in this overall energy pie chart, and coal 6%, petroleum 20%, electricity. We basically general people will basically understand what energy basically only means the electricity only. That basically contribute only 70% in the whole pie chart of the energy. So we need to understand it very clearly that the energy is not only the electricity. So there are other things we need to consider on the decarbonizations. So we often basically discuss on this only the 7% things, only the electricity. But the energy is basically not only the electricity, there are other things also. So this pie basically go into the 90% of these things still have to be decarbonized, like the 64%, 20%, 6%. So we have to decarbonize these sectors. So on the right side, you can see there are the different, where this basically energy is now we are consuming. If you see, in Nepalese context, 61% is basically used for the residential purpose, mainly for cooking. We have very few activities in this transportation and the commercial activities, you can see. And even agriculture is in terms of the energy, it basically contributes 1% to now. So that's why this agriculture sector actually basically has lots of scopes to decarbonize. I will come into details where we can decarbonize in the agriculture sector later on. So I will not go into details on this every chart. So basically, these are the different kind of this energy consumption in the different sectors. If you see like within the residential sectors, fuel wood is the major source, and the LPG is the second. So if you see this industrial, still we are using lots of coal, lots of fuel wood for this in the industrial sector. And if you see the transportation sector, it's basically the diesel and the petrols. These are the major fuels. And if you come into this commercial and this construction mining, now let me see into this agriculture things. It's very interesting. I think we have not realized these things very clearly. So if you see the agriculture sector, 75.77% still comes from the diesels. So actually, we are using lots of these fossil fuels or these petroleum products in the agriculture sector. So that's why our definitions, our existing definition of Nepal, I think it's very common in most of the developing countries. Basically, we basically understand what energy is. Energy is electricity, and it's only for lighting households. And in Nepalese context, mainly for hydro. So I think this is the kind of these wrong definitions in the overall energy sectors. So basically, not only the electricity, there are other sectors we need to consider. For example, this increase in the clean water access, clean cookings, and sustainable agriculture. So these are the different sectors where the energy is being consumed. So I think if we talk about this energy interventions, of course, it's not the kind of this straightforward or the simple linear equations. It's the multi-sectoral, it's the multi-perspectives. So what basically the decarbonization in energy sector basically means? I think this decarbonization overall basically means to reduce and ultimately eliminate these greenhouse gas emissions. That's the basic things. But how we can do with these three measures? I just summarize with these three measures. First one is this. There are ample of opportunities where we can do the fuel switching. We can, for example, switch diesel through the electricity. There could be multiple examples. Second things in Nepalese context is the strengthening the grid. Our grid, actually, we also are importing electricity from India. Now we are basically becoming the net exporter of the electricity from last year, but still we are actually importing this. I say basically the non kind of this clean electricity. And third interventions area would be this energy efficiency. There could be lots of examples where we can improve the energy efficiency in the agriculture sector. So I will not go into details about this kind of this government's priority. Everybody we know the energy sector is one of the key priority sector of the government. And if we see this, for example, the key documents like NDC 3, SDG goal, the long-term net zero, 16th plan, and this the recent Nepal's energy development roadmap that was released by our ministry. So we can see the different kind of these contributions of what energy can play in the different sectors. We can see in the agriculture sector also the document also highlight the importance and the need of the energy sector through these documents. So this is the recent document that was approved by the cabinet, this Nepal Energy Development Roadmap 2081. So you can see this Nepalese energy kind of this ambition. So from 2024 to 2035, what Nepal is aiming actually in terms of the energy sectors, you can see basically the export of the electricity also, and also expanding the use of this electricity, increasing the per capita consumption of the electricity. So, and in terms of if we talk about the decarbonizations in this also, you can see in the right side there are multiple interventions that government is planning to do while decarbonizing the energy sector. This is another important document, this NDC 3. So NDC 3 also there are lots of targets related to energy, electricity, waste, biogas, and other small kind of these interventions. You can see these different targets. I will not go into details on the numbers. So if we basically implement this NDC 3 targets, so that's the kind of this obligation to the government because of this being the signatories of this Paris Agreement. We need to accountable with this achieving this NDC 3. You can see this energy sector and agriculture sector. We can have kind of this lots of opportunity to reduce the GHG emissions from these sectors. So I'm not going into details about this energy resource potential. We know this hydro is the main energy sources for Nepal, and solar, and other kind of the resources which have multiple resources, but we have not been able to utilize these resources very properly. So in terms of this institutions overview, like in other sector also, in energy also there are multiple kind of these agencies or these government organizations who are basically working in these energy sectors. So one of them is the AEPC, where I'm working, which is basically working in the renewable energy and energy efficiency. So with this context, let me share how basically what could be the different examples, or what are the kind of these interventions that we have already made together with all the stakeholders, especially decarbonizing these Nepalese energy sectors. Let me put forward these 10 key examples. The first one, so like in other sectors, we have different projects and programs that is being supported by the different development partners. So one of the recent program which we have recently completed, that is called the Sustainable Energy Challenge Fund, SECF. So with the support from the UKAID and other development partners, you can see the logos there. So we just completed this project. And in this project, we basically had 8 key innovative windows. You can see over here. So it's not a kind of traditional kind of project, but it's the kind of innovative project, we could say. So the private sector is basically the kind of these key players, key actors who basically roll over this program. So there are basically, we just provide this viability gap funding based on this, and the payments are based on the result based. It's not kind of this traditional procurement systems project. So with this intervention, with only one intervention only, we can see the decarbonization results over here. For example, it has the multiple decarbonization initiatives in different sectors. If you see decarbonization in the commercial and the industrial sector, for example, like installing these solar rooftops, we installed this program with 26.1 megawatt, and the fuel switching, especially in the industry. For example, the industry were using this rice husk or this firewood basically for this running the boiler. So in this case, we basically replace this kind of this traditional fuels through these modern fuel sources with the pellet and the briquettes. I think this is one of the key area of this agriculture, utilizing the agriculture products on this one. The second, especially in the decarbonizing in the transport sector, you can see with this small project, we can see the many EVs in Kathmandu and in Nepal. So we installed 513 charging guns from this one. And it has this kind of this cumulative number of the GHG emission reductions. And if you see this decarbonization in the household sectors, which is most important, so this project we are promoting this electric cooking, especially induction cooking system on this one. And if you see in the decarbonization in the agriculture sector, so we just installed 189 electric pumps, including 129 solar pumps from this one, and few solar dryers, solar green dryers through this one. So this is one of the examples what actually one project can demonstrate in terms of decarbonization in the energy sector. The second example, let me come into this decarbonization in the commercial and the industrial sectors. So again, I am coming into the similar initiatives like, for example, solar rooftops with some innovative business model we call the RESCO, Renewable Energy Service Companies, where energy are basically delivered through as a service, not as a product. And the fuel switching in some industries, and also and replacing this with this briquette and pellets, and the bio CNG is another very important things. Actually, under this, actually we can already replace this around 1.45 million number of the LPG cylinders with these kind of initiatives. The second thing I just want to explain about the transport sectors, basically the electric vehicles and the charging stations. The fourth example, especially the households, because we often neglect this household sector decarbonizations, but in Nepalese sectors, the 61% energy consumption is coming to the households. So through these interventions of this improved cook stoves and the induction cooking stoves, domestic biogas, large number of the domestic biogas have been implemented. So through this, actually, that pie chart actually is actually reducing now. But we have to actually leapfrog in terms of implementing these measures in the decarbonization in the household sector. The fifth example basically is in the agriculture sector. So where the solar energy could be one of the examples we have already installed more than 4,000 of the solar irrigation pumps through different programs under our support. So in addition, there are some other interventions, for example, from the Department of Irrigation also, and Department of Agriculture. These things have been also happening, especially in the solarizing these existing diesel pumps. And let me share another examples in the decarbonization through the waste management and fertilizer and this renewable natural gas we called from the biogas. So there are two kind of interventions we are doing. One is this domestic level, very small size, the 4 meter cube, 6 meter cube plant. So another is the kind of this bigger size plants. Actually, these plants are ranging from around 4,000 meter cube to 6,000 meter cube, which one single plant can basically handle around 70 ton, 80 tons of the waste per day. So I think with managing the waste, we are not only producing this biogas or the CNG gas, also we are actually basically producing the organic fertilizer from these kind of interventions. So let me share the seventh example, especially on the decarbonizing through the forest and the agro waste management. I just talked about already also. So we have lots of opportunities to basically produce this pellet and the briquettes from these sectors. Now this Nepalese industry are basically converting or fuel switching these initiatives from existing traditional biomass to this kind of modern fuels very recently. Yeah. So another example I just basically want to, this is another project that we are implementing with the support from the government of Norway and the UNDP. So this is basically the renewable energy for resilient agriculture, agri-food systems, we call the RERAs. So basically for this rural economy in very remote places in Nepal. So this has basically in 3 key outputs you can see over here, not only for producing the energy, but also linking with this, the value chain, overall value chain of this agriculture, and also the financing mechanism has also been designed on these interventions. So where we are using this kind of this existing micro hydropowers for the lift irrigations through these initiatives, we implemented 8 lift irrigation projects in very remote places in Nepal. So you can see the kind of this their achievements or their interventions, not only for this only the lifting the water, but also the enterprise development in terms of these agro-based products and also some green job creation in these sectors. So let me share another example. This is one of these examples, the decarbonization through innovations. So we recently completed through this Sustainable Challenge Fund this captive solar PV project with the double axis tracking systems. So you can see in the picture, these solar panels, both the faces, like it has the solar PV array. Even the reflected light also can be kind of this converted through this one. And another important thing here is the agriculture is being integrated. It's called this agrivoltaics nowadays. So this is the first project we just completed in Jhapa district. So we are expecting it will basically increase the 10 to 15% of this energy increment through these interventions. So let me share this the last examples. There are many examples. I'm just sharing this few of the examples only. Another important area is basically this decarbonization through the carbon projects. We can interlink or we can basically register these projects into the carbon development mechanism, existing carbon development mechanism. Now after the Paris Agreement, we call this, it's in the Paris Agreement, Article 6. So we have already registered 8 different carbon projects, existing CDM projects. Now we are just transformed this existing CDM project into the Article 6 project. And these are the kind of these revenues. For example, in 1 year actually, through these 8 different projects, about 1 million of this certified emission reduction have been achieved. So, and the government of Nepal has already kind of this earned revenue of the 36 million USD from this carbon. So this is another area actually this government can earn the revenue and also reduce the carbon emissions through these interventions. So now let me quickly share a few slides, especially on the, I got 2 minutes remaining. Okay, I'll complete. So actually what could be the kind of the prospects and opportunities, especially into this agriculture decarbonizations. So this is one of the report that has been published last year, I think, with the support. We work together with the International Renewable Energy Agency, IRENA. The report name is called Decentralized Renewable Energy in Agriculture in Nepal. So I'm not going to explain about all the details, but in the report you can see, it's available in the online also. So they basically, in the report, they basically classify these 4 case studies, especially linking the value chain. What could be the kind of this energy interventions in the different value chain of these, for example, maize, apple, fish, and millet. And there is one graph you can see over there. So from 2013 to 2023, so the electricity sale, for example, if the electricity using trend in the agriculture is being increased, you can see 432% has been increased in the last 10 years. So it means this agriculture sector is being also kind of slowly, it's not a very fast manner, but it's being slowly kind of decarbonized, but we have to do lots of things over here. And in this report, they have already identified the different interventions areas, for example, cold storage, solar dryers, solar irrigation pumps, and the renewable energy-based mini-grids, there are different interventions that could be made. Let me share only one example from this one. That is the agricultural mechanization and processing for the maize value chain. So you can see over in the left side, there are many equipments that we are using, for example, power tiller, rotavator, and so many equipments. And you can see the fuel sources. For example, in many of the cases, we are using the diesel or the petroleum products. And if you see, for example, this the power rating, what could be the kind of this energy saving potential or what could be the energy use in this sector? If you accumulate all those things, it's an interesting figure actually. Basically, energy is required from productions, post-productions, and consumptions from whole cycle of the value chains. So they also recommended few promising areas where we can basically decarbonize through this renewable energy intervention. This is one examples. And with the investment of the 87 million USD, we can basically offset this 40% of this fossil fuel from this sector. This is one of the examples. There are other examples, and 4 examples. I'm not going into details. So let me now I'm coming into towards the end of my presentations. So besides decarbonizations, I just talk about the decarbonizations up to now, but the energy sector is basically not only for the decarbonizations, but this is basically the kind of this, as I already mentioned, it's the multi-perspectives. So it basically, you can see the sustainability prosperity can be bring through the energy sectors, especially we talk about the economic prosperity, environmental prosperity, social justice, these things, even you can see in the details, for example, in the economic prosperity, what the energy can bring. For example, job creations, industrial growth, energy security, so many things. And similar to the economic prosperity, we can see the environmental sustainability point of view also. We can see lots of these environmental sustainability things happen through the energy sector. And not only with the economy and the environment, but also the social things are also very important in our context. So providing the energy access is one of the key interventions that we need to do, including because the energy is linked with the education, energy is linked with the health. So it's a kind of this multi-dimensional perspectives the energy can bring into this picture. So this is the kind of this, what basically, how basic energy prosperity can be, or what are the drivers of the energy prosperity in Nepal. So we basically see this from these 5 different angles. The first one is the trade imbalance. Even now, if we see the import figures from the diesel, I think we are expanding much more beyond than our kind of this, than our export figures here. We are importing all those things from other countries. So this trade imbalance is basically energy actually making lots of the trade imbalance. So where now the electricity from the hydropower we can see that is being reduced. The second thing is the energy security is very important. We can see, we observe already this kind of this blockade things in last few years. We can see this energy security perspective. And third one is this, that we have lots of renewable energy potentials. We can harness those things. And there is another opportunity of the cross-border energy trading. And finally, the country is targeting for this LDC to MI, middle income countries where energy can play very important role. So this is all about my presentation. Thank you so much for listening to me. So if you have any questions, then definitely I will be happy to respond to you. So thank you so much.
Thank you, Dr. Ghimire. It was an insightful presentation. We will now transition into our technical presentations. Just a gentle reminder that each presentation is allocated 8 minutes and the speakers are requested to wrap up their presentation when I provide clue. For our first technical presentation of this session, I invite Mr. Shisher Shrestha, researcher, renewable energy, water and climate change. Thank you.
Thank you very much. Excellent presentation, Mukesh sir. It was very rich in data. So I would like to apologize for my voice. I have a bad throat. So my presentation, I'll basically look into one of the aspects, solar irrigation that Mukesh sir talked about. So in this presentation, I'll basically try to solve the puzzle of solar lift irrigation in Nepal's context. Because you see there's a huge demand for water lifting projects in Nepal, and government is also investing a lot in terms of like implementing these projects, but one see that the key problem is the sustainability of this project. So the background, a huge chunk of the agricultural land lies in the mid-hills, and most of these lands don't have robust irrigation infrastructure. Water lifting projects is one of the key areas identified by the government that could bring water to these rural communities in the mid-hills. So what I want to highlight here is basically what solar irrigation means in the Tarai. It's mainly as a climate mitigation tool, providing water access to the farmers. But in the hills, it's a climate adaptation tool. Because you see in your figure in your left, the mid-hills districts are highly vulnerable to climate changes. And you see the figure in light, it basically comes from Global Solar Atlas that show huge potential for solar in the mid-hills. So my study is basically a qualitative study, and it basically does a case studies of 13 case studies. So this is the conceptual framework. So it basically based on Boolean and Lockhart, which basically looks into what are the critical success factors that enables the project to be success or failure, right? Because critical success factors are those factors which some factors are much more important or crucial in terms of the project sustainability. And we try to identify these factors in like 4 thematic area: technology, economic, governance, and social. In terms of the methodology, as I mentioned, this is based on like 13 case studies. So the case studies sites are purposefully selected based on geographic locations, functionality status, project stages, and project size. You mean like what is the discharge, what is the head, and what is the size of the panels that are being used. And we use inductive and deductive methods to identify themes and sub-themes under that to determine the critical success factors. So I'll spend more time in this slide, a particular slide. So this basically discusses the core challenges that we found in the case study sites in the 4 thematic area, right? So I'll start with the technology aspects of the Solar Lift project. So the technology used in Solar Lift is much more different than the solar irrigation that we see in the Tarai or the Indo-Gangetic plains. So it's much more technically complex. It includes different dimensions, like civil infrastructure plays a huge role in these sort of projects, and you have to look into geohydrology. You have to take into account the flood risks that you are designing the water intake to. Another is cost-driven procurement. So as you know, in Nepal's procurement policies, so they are a mechanism to do the quality control, but it's essentially a cost-driven. So the private sector who are making the bids, they want to be clever enough to optimize their design and probably find areas where they can reduce the cost. So that in turn sometimes compromises the quality of the projects. Third is the local capacity, and by local capacity, I not only mean the capacity of the local technicians that's available to the rural communities, but also the capacity of the operator, capacity of the water user community, and also capacity of like maintaining these technically advanced what big size pumps in the local areas. Another core challenge is economic aspect is that the solar lifting projects, the project costs somewhere around like 50,000 or more in US dollars, and it's heavily subsidy dependent. And most of the government policy at the moment focuses on the upfront subsidies, and there are very little policy supports the community after the system gets commissioned. There's lack of repair and maintenance fund, so some community practice water tariffs, they collect, they maintain some side of fund. And in one of the case study site, which we selected because like we thought that would be a successful case study, and we found that like that project was commissioned like 5-6 years ago, and that system was operational for like over 6 years without any issues. But like when you check like if they have any repair and maintenance fund, so they say that they don't have enough fund. They have just enough fund to keep the system functional, but like if let's say the pump gets damaged and the size of the pumps is like over 10 HP and that would cost somewhere around like 3 lakhs NPR, they don't have that money. So if the project that we deem successful today might be non-functional like by tomorrow. So that's sort of a challenge that we're looking into. Another aspect is, so we mainly focus on access to water, but like what happens to the community after they get the water, right? How the access to water is converting into farm income. So that's not happening in majority of the projects that we see. The third aspect is the governance, right? So these are more broader sort of like issues that we found. One is the size of project that we looked into. Like we found that federal, local, and also provincial government are also implementing similar size projects. So they are prioritizing water lifting projects. They are prioritizing solar lift, but rather than like being a complementary sort of set up a program, it's more like an overlap, right? So that's an issue that we found. Transparency in resource allocation. So one community have multiple windows where they can apply for these sort of projects, but sometimes the process of selecting the projects and process of allocating the resources is not transparent. So that trickles down into the ownership of the project at the community level. Poor monitoring, right? Sometimes when you talk about ownership, it's also ownership of the project developers, right? if a government is implementing the projects, they must also note like what is the minimum number of years that the project needs to be functional for their investment to be justified, and what are the key lessons to be learned. So how many programs, where are they implemented, which area to prioritize. So those feedback mechanism is lacking, right? AEPC is doing a good job of like noting down like what's happening with their program, but like what about the national level? Like how many solar lift irrigation projects are there in Nepal? So it's very difficult to get those sort of data. In terms of the social dimensions, there are, I talk about community engagement. They are like shifting social realities due to the migration. You know? So and agriculture level availability, and also like what is the capacity of the water user community that we have. So the key, the takeaway from this slide basically is the barriers are systematic and those are interlinked. You cannot just look into one aspect. So there is a discussion around like if we want electric or solar lift, right? But we need to look into like all the four thematic areas and for the dimensions for the projects to be successful. So I don't want to go through all of the whole slide here, but like what I want to highlight is there like throughout the problems we found like 7 critical factors. These are the detailed feasibility studies, finding business model to optimize the cost of the technology, both upfront and operationals, and finding ways to improve farm income once the communities have access to water. So better transparency in terms of project selection and allocating resources, rather than like overlap between the federal government, like 3 levels of governance. There has to be a mechanism of synergizing the lift irrigation projects. Ownerships in terms of the community, how can we improve the ownership of the community, but also the ownership of the project developers. And also we need to have a robust operation management plan. So what happens after the project is implemented is much more important than like selecting a site and doing the project. All right, so this is my final slide. And so what are the key takeaways from that you need to take home from this presentation is basically 2 things, right? So when people try to do lift irrigation projects, you mainly find people discussing like which technology, will it do electric or solar, right? And what is the cost of the project and which site to implement, right? But the governance and the social dimension are often overlooked, and that is the underlying problem why there's no sustainability with the solar lift irrigation projects. And I mentioned the 7 critical success factors that the paper presents, but the key take-home message is that these factors doesn't act in alone, right? You cannot address one factors and at the individual level. So these factors are interlinked, and when you try to address these interlinked factors, you need to create an enabling environment for the technology, right? You need to look into the agriculture, food system, value chains. You need to look into the office management. You need to look into policies that support the communities after the project is commissioned. And you need to deem what are the roles of 3 levels of government when the projects are being implemented or sites are being prioritized. So with this, I'll stop here. I'm not an agriculture expert. Probably people here have more knowledge on agriculture than me. So probably I'll be willing to hear your feedback on this paper. The paper is currently being reviewed in an international journal. Hopefully it will be published like sometimes in like next 5 months. I'll stop here. Thank you.
Thank you so much. Moving forward for the second technical presentation of this session, I would like to welcome Avishek Pandey, student of Agricultural Engineering, IOE Purvanchal campus. Thank you.
Warm, warm greetings to everyone. I am Avishek Pandey, currently studying Bachelor's in Agriculture Engineering from IAE Purbanchal Campus, Taran. Today I am here to present my work, which closely aligns with agriculture and sustainability in Nepal. The title of my paper is Utilization of Crop Residue for Renewable Energy Production and Circular Economy in Agriculture, a case study in Sunsari district, Nepal. The study aims to highlight and explore the potential of production of renewable energy from rice crop residue. Starting from the reality from the farm, after every harvest, farmers are left with a large number of crop residue. In most of the cases, farmers have been seen burning the crop residue openly in the farm. From the farmer perspective, it is seen that this method of crop residue management is quite cheap and quite cheap and convenient method of crop residue management, but open burning of the crop residue results in air pollution, greenhouse gas emission, loss in soil nutrition. The study doesn't look this issue as a problem, but also look it as a missed opportunity for the production of renewable energy. The objective of this research is quite simple and practical. The research aims to estimate the total rice residue in Sunsari, along with the total theoretical renewable energy potential of the Sunsari district. Also, this research aims to examine whether this approach aligns with the circular economy framework or not. Sunsari district lies in the eastern part of the Tarai region. Because Sunsari district produces a large amount of rice, and due to the increase of the open burning problem in the Sunsari district, this district is selected as a study area for the research. This paper is truly based on secondary data and quantitative analysis. The data for this study is used from the reliable source such as Ministry of Agriculture and Livestock Development, Central Bureau of Statistics, FAO, and published researchers. For this study, rice is selected as a major crop. In simple words, in this study, we determine the total rice residue, surplus rice residue, and energy potential. As the result, it is seen that in Sunsari, rice cultivation is dominate the agricultural landscape of the Sunsari. It is estimated that around 230,000 to 360,000 megaton of rice residue is produced annually. Of course, not all rice residue is available for the energy production. In case of the Sunsari district, around 50% of the total rice residue is available for the further energy production. With the use of the excess or surplus rice residue, around 727 megawatt hour energy could be produced annually in the Sunsari district. From the economic perspective, this approach would result in providing the local employment opportunity, along with reduction on dependency on the LPG and fossil fuel additionally providing an extra income opportunity to the farmers. Whereas from the environment perspective, this could result in reducing and addressing the major problem of open field residue burning, ultimately resulting in lowering the greenhouse gas emission and improving the air quality. As this approach aligns with the circular economy model, firstly, the produced rice residue is, some part of the rice residue is used within the farm, and other surplus part of the rice residue is used for the energy production. The generated renewable energy from the rice is again used and support the agriculture and livestock activities. Further, the byproducts such as biochars is again returned to the soil, improving the productivity in the long term. In a conclusion, these papers demonstrate that there is a strong potential of generating the renewable energy from the rice residue in Sunsari district, along with reducing and utilizing the clear environment and economic co-benefits. Since this paper is truly based on secondary data, further a field level survey is essential to understand the real practice in the farm, and detailed techno-economic studies should be carried out to select the suitable technologies, and further life cycle assessment should be carried out to understand the long-term impact of this approach on the environment. Thank you.
Thank you, Avishek. It is a notice that there is a QR placed on the table that to receive your feedbacks, and we are also providing all the papers on the email after you provide your feedback there. For the next presenter, I would like to request Min Bikram Malla, Thematic Lead Energy Practical Action. I don't know what is written here. I'm given this. Yes, let's welcome Min Bikram Malla ji. Thank you.
Good afternoon. I am Min Bikram Malla from Practical Action. Here I'm going to share the evidences of energy audit we carried out in dairy value chain, and field intervention we carried out based on the study. Why energy efficiency is important for dairy value chain? First, I want to talk about this. Dairy is one of the most energy intensive agricultural value chain. Energy used in all value chain, from production, collection, processing, and retailing. And it is dominated by inefficient electrical equipments. Polluting fuel use like solid biomass and diesel is very high. So it is resulting to high production cost, low productivity, and high emission. So to understand it properly, what is in actual real value chain, we carried out energy efficiency audit across the dairy value chain with the help of technical experts from Rashtriya Urja Dakshata Kendra. The study was carried out in Baglung and Makwanpur. Main our objective was to identify real bankable efficiency opportunities in dairy value chain. I don't want to go in detail on what we did, methodology. What we found, what the study found energy wastage, energy inefficiency in 3 main aspects: in the electrical side, in thermal side, and also in operational side. In the electrical side, we found that there are use of old motor, compressor, poor insulation in chilling system, low power factor, inefficient refrigeration. And in thermal side, we found that traditional heating practices are there, no condensate recovery, biomass boiler with high heat loss there. And also we found loss in operational side also, poor layout, manual practices where efficient machine exists, that we found. So it is not only technical, it is also behavioral and system that is leading to inefficiency. In terms of number, we try to capture the number also. I'm referring here only the findings of Baglung, where we did. And these numbers are from the actual sample industry and dairy farm and household only. So it may look little. We found that in those sample industry farm, electric saving, we can do electric saving of about 42,000 kilowatt hour per year, and thermal fuel saving of 5,840 kg. That is the biomass equivalent fuel, and cost saving of 576,000 per year, and emission reduction of 12.2 ton carbon emission reduction in electrical, if we do in electrical part, and also 9.5 ton carbon emission per year in thermal part, total 21.7. I'm again saying that the number seems insignificant, not that large, but it is actual reduction we can achieve in one industry, one farm, and one household. Only the sample number was little, so reduction. But the message is that we can save energy, we can save money. This is the finding. Based on the findings, practical action, we carried out intervention also. We combined the technical evidences with productive uses of energy technologies, energy efficient equipment promotion, repair and after sales ecosystem. We try to build on after sales services and build capacity of farmers and SMEs. And also we try to develop market system. We worked on market system approach, and we promoted, we supported few technology promotion also. We supported solar water heater, electric chaff cutters, deep freezer, cooling tower, water coolers, improved cook stoves, cream separator, paneer making machines, and many more with challenge fund approach. And why this type of intervention matters for energy for dairy sector? Because energy efficiency directly increases farm income. It reduces pressure on national electricity demand, and it delivers fast climate mitigation climate mitigation potential is also very high. So for agricultural transition in Nepal, first we need to fix energy inefficiency across value chain, dairy value chains, and also provide adequate energy and technologies. If we do that, dairy sector can lead Nepal's low carbon energy transition. And my organization, Practical Action, is committed to move this forward. With this note, I want to conclude here. Thank you. Thank you very much.
Thank you so much, sir. Moving forward, now I would like to request Engineer Shisher Shrestha to present his poster presentation of his findings. You can see it on side screen, and I also request him to conclude his key points in just 2 minutes. Thank you.
Namaste, good afternoon everyone. Respected session chair of this theme, Rural and Renewable Energy. Our special guest from India, Syed sir, and Bangladesh, Mr. Chain sir. Our other special guests from different organizations. Our different speakers, our keynote takers, and all participants. You can see my paper poster inside screen, but I think it is not clearly visible. Due to the time limitation, I would like to conclude my presentation in short with my key points. In context and problem, rice is crucial for Nepal's food security, contributing to nearly 1/4 of agriculture GDP, yet productivity remains low. And the key challenges include the climate variability, erratic rainfalls, rising temperature, and inadequate irrigation. To address water energy challenges, solar irrigation projects are being promoted in the Tarai, including Zappa. And the research focus and objectives are: the study evaluates the solar irrigation as a climate-smart solutions for paddy production. Especially, it analyzes climatic trends, crop water adequacy, productivity, and carbon reduction, and gender and socio-economic empowerment. And the study was conducted in Kathmandu Rural Municipality of Zappa district, and the methods is mixed method approaches was used, where climatic trend analysis was found by main candle slope, sand slopes, and crop watt for the water requirement, and FGT, KII, and field measurement to assess the productivity, general role, and emissions. And the key results: rainfall is variable with slight temperature increases, and solar irrigation projects fully meet the spring paddy water demand and partially supports the monsoon crops. And paddy yield is increased significantly under solar irrigation, and the solar irrigation projects reduce the emission by about 36.66 metric ton of CO2 compared to diesel pumps. And in conclusion, way forward, solar irrigation is an efficient climate-smart technology for sustainability paddy production. However, the high initial cost and moderate gender disparities still limited wider adoption, and targeted subsidies, inclusive trainings, and institutional supports are essential for the scaling solar irrigation projects sustainability. Thank you.
It was a short yet meaningful and informative presentation by Mr. Shisher Shrestha. Now I would like to welcome Navin Vandari, Mechanical Engineer, Asta Engineering Solution, as a last presenter of this session. Thank you.
Namaste and good afternoon, everyone. I am Navin Bandari from Asta Engineering Solution Private Limited, and today I am going to share the evidence from Nepal on solar greenhouse dryer for the agriculture value chain and how our community based renewable energy partnership model was actually implemented. It was a case study report from Palpa and Sengja district. First start with the background, why this matters. Because most of the rural farmers in Nepal are dependent on the open sun drying for their crops. They dry their products in the open sun, but they are exposed to dust, and they are also weather dependent, and insect and contamination also occurs when they dry their product in the sun. So due to this, the post-harvest losses is a critical factor for their cases, and due to this, the farmer loses the value and lower and the income also decreases and also makes the rural economy weaker. This is the flow chart that I have presented here. The post-harvest loss means the low income, and which means the low rural economy. And our intervention, the loop that we are trying to break is the how the post-harvest loss and the low rural economy can be broken. And for this, we have installed the 10 greenhouse solar dryer in Palpa and Sengja district. Each solar dryer has a capacity of 250 square feet, and the total combined area is 2,500 square feet. And it is a community oriented and community focused solar dryer. So in this dryer, the farmers bring their products and they dry these, and the community and the cooperatives also helps them to get the market linkage. And it also focuses on the climate smart value addition using the solar energy, and no other forms of energy are used beside the solar energy in this solar greenhouse dryer. You can see the picture of different dryers in the Palpa and Sengja district, and the products that are being dried in the solar dryers. And now let me explain what is the main solar dryer concept and how it is differ from the open sun drying. The solar greenhouse dryer is a closed chamber. It is enclosed with a polycarbonate sheet, and the sunlight enters the sheet, and the temperature inside get quite higher compared to the surrounding temperature. And we have the system to control the humidity, temperature, airflow, and which makes the drying efficient and more controlled compared to the open sun drying. And also it creates a better hygiene compared to open sun drying due to the less contamination from insect and other weather-related activities like the damp, moisture, etc. And I have also created a small flow chart on how the greenhouse solar dryer works. The farmers from the farm, they bring their product into the solar dryer that are community-led, and they grade the products, like they slice, chop, and wash the product, and they dry in the greenhouse solar dryer. They are equipped with the food material grade trays so that they are totally hygienic and they are dried with consistent. And we have also the electrical and the air condition that system, and also we have also incorporated the heat pump so that the drying can also be achieved in the rainy season and monsoon season. And after they are dried, they are collected and packaged with proper labeling, and they are sent to the market. Currently, we are supplying the foods to different industries like CG Foods, and other markets also. And you can see the pictures of the two different sites, the Palpa site and the Sengza site, where our solar greenhouse dryer are implemented. And we can see the product that are being dried in the solar dryer also. And how the value chain is supported by the solar dryer is the main concern. The solar dryer enables the processing of the fruit, vegetable, and spices and makes their market value higher. Like the farm produce get processed and they are dried in better quality, consistency, better moisture content than open sun drying. And after that, they are packaged and supplied to different markets. So they also have the better, longer life compared to the open sun-dried products, and also add the value. Our product have more demand from the consumers and other industries like the CG Food. They have also given us better review for our products. So this increases the value chain. And other thing that how the value chain is supported is that the things that are seasonal, like the cabbages and hawk plum, that is lopsy, and other akabare khorsani, the chilies, they are seasonal products. So after their season is expired, or after the off season, we supply the product that are dried in our solar dryer, so the farmer can get the better income and how the value is added to their products. And our case study has shown that the drying time has also reduced compared to the open sun drying. Our solar greenhouse dryer reduces the drying time by about 40 to 60%, but it depends on the what type of fruits or whatever vegetable that are being dried. It depends on their moisture content and their consistency also, but comparatively they are dried 40 to 60% less time than the open sun drying, and the product that required around 3 days of drying in the open sun can be dried in 1.5 days, and the incorporation of the heat pump also reduces the drying time by very less. And now moving on to energy and emission impact. And our solar dryer replaces the fuel-based drying that are very common in the hilly and mountainous region of Nepal. They dry the products like the meat and other sources using the fuel wood, and our estimate is it saves or displaces about 2-3 tons of biomass each year, and the benefits that we get from this is lower emission, less smoke exposure, and also decarbonizes the agriculture processing industry. And beneficiaries and inclusion. Who are included in our greenhouse solar dryer product and how they are benefited? Our initiative currently has benefited more than 250 farmers, and among them 60% of the farmers are women. And since it is a cooperative owned project, they are managed by the community people, and they are being accountable by the community members also. And this is a small pie chart that illustrates the participation of women, and they get stronger roles. Women get stronger roles in the processing and income activities, so they can be independent also. And income and market outcome. Our product has gained a popularity in some marketplaces and have high demand in market, and the value addition that the farmer get from their dry product has increased their income about 20 to 25%, and the product life also can be stored longer and access to high value market. So they are not forced to sell their product at the low price, but they can store the product and sell there when the price rises. And these are the products that are obtained from the greenhouse solar dryer. You can see the ginger powder and some maseuras and other dried bitter gourd, etc. And our partnership model. How we not only develop the, we not only deploy the infrastructure, but also provide the capacity support, market linkage, and in one integrated model. And the community ownership also increases the accountability, and technical support improves the standard and product quality. And the small flowchart of the implemented ecosystem is also shown in the figure. Now I have less time, so I have to rush on my presentation. So what are the implementation lessons that we have learned is that the cooperative ownership increases accountability, technical support increases the quality consistency, and market linkage is the real income lift. And challenges is the packaging and grading standard, maintenance planning, and seasonal raw material supply consistency. And replication model is it is off-grid friendly, so we don't have to depend on the electricity or other kind of energy for the drying, and also a strong fit for rural and hill district where the clean energy options are limited. So the replication are mainly for the replication hotspot is mainly the mid hills, rural clusters, and cooperative hubs where we can replicate the model, and they are very scalable as we can see. And lastly, there are 4 takeaways that the presentation has provided. The drying time has reduced. Estimated biomass saving is around 2-3 tons per dryer per year, and the reported income increase is 20 to 30% compared to the open sun drying due to the market linkage and value addition. And the community-based partnership models increase the accountability, and the members are being accountable for what they own. So saying this, I want to conclude. So thank you very much.
Thank you. Now, moving forward, we are having discussion and question and answer sessions. But we are already 45 minutes behind our schedule, as our Honorable Minister, Agriculture and Livestock Development is on the way to the venue for the closing ceremony. I sincerely request everyone's cooperation on this session. To facilitate this session, I would like to request our session chair, Mr. Chain sir, to facilitate this session. Thank you.
Thank you, everyone. Good afternoon. Actually, it's really nice to hear presentation from the experts, academicians, students, and practical users, especially from the entrepreneur. Let's give a big round of applause for them for this presentation. So now we'll have actually questions. So if you are, so please, we can take 3-4 questions and then come to the speaker for answering.
My question to AEPC Director, Dr. Ghimire. How hopeful you are that alternative energy will fight out climate change? First question. Second question, you have been dwelt with furnace oil and coal, which are so detrimental for climate change. Yeah, that's fine, thank you.
So please there, yeah.
Hello. My name is Sachin Gumarja. I am from IU Purvanchal, Dharan. So my question, I have 2 questions. One is for Avishek Pandey. What are the economics benefits for the crops residue utilizing compared to the burning? And the last question is for the Mukesh sir. What are the challenges for you to work on the decarbonization in Nepal?
Anybody else? Okay, please.
My question goes to Dr. Mukesh Ghimire. why wind energy is not harnessed in Nepal?
I don't have question, but I have three observation to share with the colleagues sitting in this room. My first observation relates to, it relates to we taking for granted that investment in irrigation, it produces productivity increase, okay? Now, what Shisher ji from IWMI presented, investment in solar irrigation, it really has not produced quantum increase in agricultural productivity and income of the people, okay, in the area. It's not isolated case. In that particular case that you talked about, if you we look into, the case of large irrigation systems in the country, okay, for example, Gandak irrigation project, okay. I mean, look into the history that irrigation system came into operation in 1976, okay. It was providing year-round irrigation. Electricity was available in the area. Connectivity was developed, okay? But if you compare now, the livelihood of the people in the area compared to adjoining districts of Chitwan and Rupandehi, it is much, much lower, okay? So, then it raises the broader question, okay? Are we agricultural scientists sitting at in Nepal Agricultural Research Council, are we focusing irrigated and on non-irrigated area differently in terms of producing appropriate agricultural production technology? Okay, and then are we delivering right package of extension services which really caters to, need of farmers in irrigated and non-irrigated areas to, make value contribution in agricultural productivity increase. So this is my first observation. My second observation is...
Sir, please be brief because we have only 15 minutes.
Okay, my second observation, it relates to, the way crop residues are burning all across Tarai. It's not only rice straw which is burned after harvest, wheat is equally burned. And this situation, it prevails all across Tarai. So probably, we need to think a smart way of, making value addition to this evil activity which is going on in the region. And my submission is, I was reading through papers, and one of the in one of the technical article I happened to read that this straw can be converted into pellets as livestock feed. So if there are colleagues sitting in the room, who have done any work or thinking to do any work on converting rice straw into useful animal feed pellet, we would like to listen to them.
Thank you, sir, for thought-provoking comments. Here, actually, someone wanted to, you wanted to ask something? So please.
Namaste.
Yeah.
My question is for Shisher Shrestha, sir. He has typologically identified 4 challenges: economic, technical, governance, and social. My question lies on economic as well as social challenge. While setting up the infrastructure for lift irrigation, large type of lift irrigation, the heavy infrastructure covers the huge land. So there might be a dispute or clash between the farmers who can lose that, farmland for the installation purpose. So how would you overcome this challenge that is economically valuable as well as its countable agriculture production? Thank you.
Okay, thank you. Let's get answer from the speaker. First, I would like to request Dr. Ghimire to answer the question. Yeah, please. Can you check that?
Yeah, thank you so much. I have received 3 questions from the floor. The first one is basically how you are thinking about this alternatives, role of the alternatives energy, especially in the decarbonization and the climate change. And there was kind of this associated question related to the how we can deal with this the coal and the oil things and these things. So let me answer this question first. So I think this, of course, if we talk about the renewables and if we see these renewable trends, for example, this especially solar. So if we talk about these things maybe 10, 15 years, 20 years back, then I think everybody was basically considering solar as just only alternatives. But I think now we can see in many of the countries, even they have the very resource in the fossil fuels, they are now actually transforming these things into this solar. So I think the main key factors basically are one is the cost. The cost have been significantly kind of this reduced. The second was this, the beauty of this solar is basically the very kind of, we can install these things very easy, very quickly. The second thing, and there are many innovations within solar also. For example, in terms of the technical efficiency also, initially it was only 10%, 12%. Now these have been significantly introduced. So I think so with this kind of these interventions and the growing trend of this renewable energies in the world, so I think this alternatives energy definitely can significantly contribute for this decarbonizations. But there are several areas where this, which we call this in terms of this climate change, we call this hard to abate sectors. So for example, where we cannot actually transform all these kind of these existing fuel sources through the solar because of the very high energy intensive industries. So I think in that cases, it will take some gradual time on this one. But I think in many of the cases, like I mentioned in the different sectors, the solar can definitely contribute on this one. The second, basically, yes, this oil and this coal. So I think we also need to understand this, some of these fundamental elements on this oil and coal things. So these are not only the kind of these tradable energy sources. So there are kind of these many things in the back end. We can see that this Russia-Ukraine war, the geopolitics, how these geopolitics affect this overall value chain of the coal and oil. Even we can see this how in that era also how India plays the role, especially importing this coal and oil from the Ukraine to India and then to Europe, because European country actually did not buy directly from the Ukraine. So I think on the coal and oil, I think there are some other dimensions also. One is the geopolitics and another economics. So in terms of the economics, these things have been kind of this cost have been being increased, wherever it is otherwise the renewables cost have been decreased. So I see these decarbonization initiatives can be possible. So, but I think the gradual decarbonization initiatives can be possible through these alternative means. The second question was basically what are the challenges in decarbonization in Nepal. So I think there are a couple of challenges I see. The first one is basically this behavioral thing also, because in behavioral things also related to these regulatory measures. For example, if I have the industry, then I don't have the kind of this regulatory requirements to meet some kind of the minimum performance energy standards or some of this kind of this pollution requirements. If I don't have this mandatory requirement, then why I am going to switch this from existing kind of this fuel sources to the another one? So for that, one is the kind of the regulatory measures. This is still not quite clear in Nepalese context. The second one is the cost also, because everybody will basically to look into the cost factors here. Either they have to be kind of this regulated very well, through command and control kind of the policies, or some of these kind of these cost interventions, because the cost, even these renewables still are costly in some of these energy kind of switching things. And these are some of the kind of the challenges that I see from my perspectives. Then third question was related to the why wind energy is not harvesting in Nepal. Yes, I think there are a couple of reasons. The first one is the resources. The resources are mainly kind of these available, wind resources are mainly available in this very high kind of this very difficult terrains, especially Mustang and those areas. So I think this is one of the reasons that we cannot actually harness the large scales winds. So of course there are already some interventions around 113 kilowatt of the wind, 130 kilowatt of the wind systems have already been harvested, but it's not in the very large scales. Only the 20 kilowatt, 30 kilowatt kind of the smaller systems have been we are working on that one. The second thing is also we also have the one failure example actually, when we also need to be very careful while implementing the technologies. So if in the wind case, so there is some of the failure cases in Mustang in the very initially, then actually that actually lose the confidence actually to the people or to the investors on that one. Second one, and third one is in comparison to the cost, because we also need to compare the cost in comparison to the wind. Like other technologies, especially hydro and solar, are most quite cost competitive. I think these are the kind of these key challenges why wind is not kind of this. We are not promoting the wind energy in the large scales. Thank you so much.
Thank you very much. Mr. Avishek Pandey, are you here? Could you answer the question of the audience?
Thank you for the question. Regarding the economic benefits of the crop residue utilization, instead of the burning, if we utilize the crop residue for the energy production, it could create an extra income opportunity for the farmer. For example, instead of burning the crop residue, if farmers utilize it for the renewable energy productions in form of briquettes, pellets, or biochar, also in form of biofuels, it would be the extra source of income for the farmers, and also it would be helpful in supporting the small industries in local level, providing a local employment opportunity. Thank you.
Thank you. If you have any further question, you may ask him or discuss later on. So, Mr. Shisher Shrestha, please.
Okay, I would like to thank Asutosh sir for the remark. I think that's something we need to think about. That's definitely. So coming back to the question that I had, so regarding the economics of doing a large-scale project and then dealing with the community dynamics. So I have two answers for this. One based on my personal experience, and one what the paper says. So I'm an engineer. So the technology, electromechanical, is of the thing of my interest, right? But over the years, what I've learned is you can get away with over and under design. If you are designing a system that needs to deliver 20,000 liters of water, and if the system delivers only 15,000, you might be able to get away with it. But if you don't address the community issue, then the project's failure rate, the probability would increase drastically. So based on my paper, so we basically identified 7 factors, and one of them was detailed feasibility study. And by detailed feasibility study, I don't mean what technology, what head, how much water to deliver, right? We need to look into what does the community want. So it's not like a solar lift irrigation project's detailed feasibility study or electric lift irrigation detailed feasibility study. It's a energy neutral study we need to do, and we need to check what the community wants. If they want a larger system and they think that they can manage the community dynamics, then that should be the way to go. Or if they want multiple smaller systems, then maybe that should be the way to go. So it's basically the community's demand should be addressed. Yeah.
Thank you, actually. I think, okay. Please.
The rice paddy stock is very commonly used in South India, and TNA has done already pellets for the feed. Cotton stock has been done last 2 years back, IIT Bombay. Very successful now. There's entrepreneurship taken up. Cotton stock also, animal feed is very good. So just for information.
Thank you very much. Actually, we are not going to take any more questions. If you have any questions, please email the respective presenter or discuss later on in the tea break. Probably I have to summarize. I can just, so actually the presentation actually given today, there were 6 presentations. Actually, the lead presentation by the Dr. Mukesh Ghimire was really eye-opening, thought-provoking. Actually, he covers everything that I would supposed to summarize. So actually, he talked about the solar energy, biomass-based briquette, pellet, and biogas energy, as well as the option to having biofertilizer. At the same time, he talked about different options and areas of actually where we can promote, inject clean energy to have a reduction of greenhouse gas emission. So it was really nice to hear what APCs are doing. It looked like the similar trend that we are having in Bangladesh. Like it's a 3% coverage renewable energy here in Nepal. In Bangladesh, it's also like 3.57%. So it's like probably we are moving towards forward parallelly, but the things actually we have to think together. And then there were presentation from Shisher Shrestha on the solar lift irrigation. It's a kind of elaboration or kind of case studies what Dr. Ghimire said. So it's really see that we just don't need to think about the technology and economic. We have to think about the government policy and the social aspect when we want to actually inject or we want to propagate and disseminate the renewable energy-based technology. And Avishek Pandey actually, being a student, he presented very well regarding rice biomass-based energy. Actually, though it is a theoretical study, but it's a kind of evidence and position that we can think of, and we can have a more practical of this outcome through the experiment and validation work. And Mr. Bikram Malla from Practical Action, actually I could see the only presentation who talked about the livestock. So it's about the energy efficiency in the dairy farming. So we cannot think any agriculture, actually that crop, fisheries, livestock should go together, hand to hand. So whatever we are talking about, our engineers right now need to think about, talked about the circular bioeconomy systems. So it should be part of our curricula, where actually you can see from the crop, which we cannot eat, that can be feed for the livestock. And what livestock actually providing, they are providing us food, at the same time they are generating waste. That energy can be used for, producing electricity or for crop production or some other issues. At the same time, we are getting biofertilizer. So it's generating soil health. So we people need to think of about, circular bioeconomy system. Dr. Shukla sir also pointed the words. Also, our students also said about the bioeconomy, but we called it the bioeconomy system as an engineer. So we have to think of that. And also, there was one other issue from the actually ASTA solution. I think it's a young entrepreneur ASTA solution. They're providing solution to reducing the post-harvest loss. It's also the circular bioeconomy system, because we need to reduce the loss. At the same time, we need to reduce the waste or generate energy, or we want to process to value-added products. So it's really good to see that things are happening in the field. And also, Somit Shrestha talked about the solar irrigation for paddy production. Though he talked about the gender empowerment, probably we could hear more on the gender empowerment, because without gender involvement, we cannot do much because as you see the population growth and the ratio, the women are playing very vital role in vital position. Another thing that I would like to say, actually, that probably you all know that internal combustion engine, fossil fuel-based engine will be not there. By some of the company will stop producing this internal combustion engine after 2039. So we have to be ready for the next challenges, being in the developing countries. So the things are moving towards more of EV vehicle. As for example, for transporting our goods from village level to market, we need a kind of logistical support. We have to think of that on also. At the same time, actually in the agriculture, alternative option also we need to think of electric-based solution. If we want to adopt solar irrigation system widely in the agriculture, as I saw it also in the Bangladesh, the 40 to 60% energy from the solar irrigation system are being utilized for the irrigating, but rest of the remaining of the energy is sitting idle. So we need to think of alternatives. So that the system can be profitable. And I just actually close my talk with saying the word, we say climate smart agriculture. It's the main theme of the climate smart agriculture. What is climate smart agriculture? We need to increase the productivity. We need to adopt the technology for increasing the efficiency and actually avoid this climate impact. At the same time, there's a word that's reduce and reuse. So we need to reduce the emission. We need to reuse the product or bioproduct for making it a value-added product. So it's really very important. And with this word, actually, I conclude my words and also conclude this session. So thank you very much for listening, and thank you, presenter and the keynote taker, for taking this very important note. So thank you all.
Thank you so much, Professor Dr. Chayan Kumar Saha, sir, for his brief remarks. Now we have reached a very special part of our program. To show our deep appreciation for the expertise shared today, we would like to present a token of love to our session chairs, keynote takers, and all the presenters. For that, I would like to request our guardian, our senior agricultural engineer, Mr. Mahendra K. Yadav, sir, in the stage. I would like to request sir to hand over the token and our session chair to receive it. Please give them a big round of applause. Now, to provide tokens, I would like to request our agricultural engineer, Piyush Kumar Sharma sir on the stage. And to receive the tokens, I would like to request our keynote takers of this session. Sorry. Now, I would like to request all the presenters of this session to receive their tokens. Respected Dr. Mukesh Ghimire, Mr. Shisher Shrestha, Avishek Pandey, Mr. Min Bikram Malla, and Naveen Bhatrai. Thank you.